this video, we are going to see the behavior of light when it passes through the converging lens. Here you can see three laser guns emitting three incident light rays. Incident light rays are the light rays that enters the converging lens. We can see here three incident light rays. When they pass through the lens, they undergo refraction. What is refraction? Refraction is the bending of light when passes from one medium to another. Air is a medium, glass is another medium. So when light passes from air to glass, it will undergo refraction. And when it passes from glass to air again, it will undergo refraction for the second time, thus bending the light rays in this direction. We can see here three emergent light rays leaving the lens. They converge to a point. Converge means that they intersect at a specific point. This point is called the image focus, represented by the letter F prime, or it's also called the focal point or the principal focus. Now, we can represent the lens by the ray diagram or the diagram representation of the lens. We represent it by a vertical straight line with these two arrows. We can draw also the optical axis perpendicular to the lens at its midpoint. This optical axis, x prime o x, it's a virtual imaginary line. It's drawn only to describe the incident and the emergent light rays, as you will see in the following three rules. Now, let's remove the lens, just work at the diagram representation, the ray diagram. We can see here that O, it's called the optical center. The optical center, it's the center of the lens. F prime, as we said before, it's the image focus, and x prime OX, it's the optical axis. Now, we can describe the path of this specific light ray. We can see here that the light ray is incident in a way that it's parallel to the optical axis. So when it comes parallel to the optical axis, it will leave out of the lens, passing through its image focus. So the rule goes like this. Any incident light ray, it means that the light ray that enters the lens, passing parallel to the optical axis, it leaves the lens, passing through its image focus. So the emergent ray passes through the image focus, F prime. This is the first rule for the path of the specific incident ray. Now the second rule is when the incident ray is passing through the O, which is through the optical center of the lens. So the rule goes like this. Any incident light ray passing through the optical center leaves the lens without deviation. What do we mean by without deviation? Without deviation means without bending, without changing the direction of the light ray. So the light ray continues its path without changing its direction. We say that it leaves without deviation or it leaves undeviated. We are not obliged to turn the light ray passing along the optical axis. It also may pass above it, but also passing through its optical center. So when it passes through the optical center, it also continues undeviated. This is the rule. Any incident light ray passing through the optical center, it will leave without deviation. This is the second rule. Now, the third rule, when it passes through another point, it's called the object focus. Now, before mentioning the third rule, we want to introduce a new point. It's called the object focus. Taking the symmetric of the image focus with respect to the lens, we can introduce the object focus. So symmetric means it's the same distance. Between O and F prime is the same distance between O and F. So we can say that OF is equal to OF prime. They are symmetric to each other. F is the symmetric of F prime with respect to O. What is F? F is the object focus. F prime, it's the image focus, and O, as we said before that, it's the optical center. So the distance between O and F is equal to the distance between O and F prime. Now, we want to send a light ray passing through the object focus. It leaves the lens passing parallel to the optical axis. So let's look at this rule. Any incident light ray passing through the object focus, it will leave the lens passing parallel to the optical axis. Thank you so much.